A cone has a circular base and a vertex that is not in the same plane as the base. The radius of the base is the radius of the cone. The height is the perpendicular distance between the vertex and the base. In a right cone, the segment joining the vertex and the center of the base is perpendicular to the base, and the slant height is perpendicular to the base, and the slant height is the distance between the vertex and a point on the base edge. The lateral surface of a cone consists of all segments that connect the vertex with points on the base edge. Let's take a look. Okay, so here's the cone. You can see the base of the cone is a circle. All right, and the radius of the cone is the same as the radius of that circle. So right there is your radius R. And you can see the cone, the lateral faces of the cone meet at a vertex. Actually, I should say lateral surface, not lateral faces. Okay, so everything on the cone other than the base, that's the lateral surface, and it meets at a vertex point here. The height is the perpendicular distance from the vertex to the base. Okay, and see, it makes a right angle with the base. So that right there is the height. Usually we call that H. And the slant height is the slanted distance along the side of the cone. We usually call that L. So that's your slant height L. This is your height H. And this is a right cone. So the vertex is directly above or below the center of the circle. Now, to find the surface area, we want to separate the lateral surface and the base so we can add them together. We know the area of this circle is just pi r squared. But before we get to that, this circle right here, they just drew it right here in red. Okay, so this red circle is your base. And the radius is R. However, if you unroll the lateral surface, the part of this cone that is everything other than the base, if you unroll this part of the cone, it's not going to be a full circle. Okay, it's just going to be a partial circle. And this distance right here on the side, this distance right here is L. And when you unroll this part of the cone, this becomes the radius of this partial circle, okay, which is basically just a sector. Okay, a sector is just a part of the area of the circle. So we basically have a circle base, and we have another partial circle, which is a sector, but they have different radiuses. This radius is R, and this radius here is L. Now, I'm going to make two fractions. I'm going to make one fraction the circumference, and I'm going to make another fraction the area. Okay, so these fractions are going to equal each other. And in the numerator, that is just going to be the part or portion. And in the denominator, that's going to be the whole circle. Okay? So as you can see here, this sector, we only have part of a circle. So the circumference of this part of the circle, they labeled it from here to here. That's just 2 pi r. How do we know that? Because if you rolled this base right here around this sector, it would go from here to here. So the circumference of this circle here is 2 pi r. And that distance around this circle is going to match the circumference of the partial circle, which is a sector. So the circumference of the part is just 2 pi r. Now, if this right here were a whole circle, the circumference of this would be 2 times pi times L, because R, the radius, is just L for this sector. So that's going to be 2 times pi times L. And now for the area, The sector area, we don't know. Okay, so for the area of the sector, we can just call that A sub S. Okay, so for the area of the sector, we're just going to label it A sub S. So that's the area of the part, because this is just part of a circle. And the area for the whole circle, if this were the whole circle, we know the area is pi r squared, but you plug in L in place of r, so that's going to be pi L squared. Okay, because the radius on this is r. The radius on this is L. And now if you cross multiply, we have 2 pi r times pi L squared and we have 2 pi L times A sub S. That's the area of the sector. Now, if we want to solve for that, the opposite of times 2 pi L is divided by 2 pi L. We're going to do that to both sides. And now you can cancel easily. 2 pi over 2 pi cancels. L squared divided by L is just L. 2 pi L over 2 pi L cancels. We have R times L, which is pi RL. And that equals the area of the sector. So the area of the sector is pi RL. Okay, and we know the area of the circle base is pi r squared. So now we're in business. The surface area is going to be pi r squared plus pi RL. And that right there is the surface area for a cone. So that's what they say here, surface area of a right cone. Surface area is B plus 1/2 CL, then that equals pi r squared plus pi RL. I'll show you another way how we got this. Okay, you really don't have to worry about the first part. This is the formula right here. Pi r squared plus pi RL. Okay, but I'll show you another way how we got this right here. This was the formula we used for a pyramid, for the surface area. Okay, but for a cone, the base is a circle. The area of a circle is pi r squared. And that's going to be plus, not equals. So that's going to be 1/2 times the perimeter. The perimeter of the circle is circumference, and the circumference is 2 pi r. And that's times L. So that equals pi r squared. 1/2 times 2 cancels, and you're left with pi RL. So once again, same thing that we just had before. That's the surface area for a cone. All right. Example 3, what is the surface area of the right cone? Before I go to the diagram, notice all of the answers are in terms of pi, so I am going to leave pi alone. Okay, so we said the surface area for a cone, that's going to be pi r squared plus pi RL. As you can see, we do not have L. This would be L right here, this distance from here to here. So just like we did with the pyramid, we have to use the right triangle that's inside the cone. All right, we're going to use Pythagorean theorem. So let's do a squared plus b squared equals c squared. All right, across from your right angle is always c. So that's your slant height L. A and b, it doesn't matter, so I'm going to let a equal 6. And this right here is 8, so I'm going to let this equal b. That's 8. So a squared is going to be 6 squared. B squared is going to be 8 squared. And c squared is going to be L squared. Okay, you can do this on the calculator or just take the square root of both sides from here. I know this is 36 plus 64, so that's just 100. And that equals L squared. And now taking the square root of both sides, square root of 100 is just 10, and that equals L. So now we're in business. We have L. All right. So the surface area for the cone, pi r squared, that's going to be pi times this right here is your radius. Okay, remember the radius of the cone is the radius of the circle base. So that's your radius. In place of r squared, I'm going to do 6 squared. And that's plus pi times r. Once again, that's 6. Times L, which we just found. We said that was 10. All right, leave pi alone. 6 squared, or 6 times 6 is 36. And that's times pi. 6 times 10 is 60, and that's times pi. And 36 plus 60 is 96. And that's times pi. All right, the units were in meters, but for an area or even surface area, the units are going to be meters squared. So 96 pi meters squared. And that is answer B. Example 4. The traffic cone can be approximated by a right cone with radius 5.7 and height of 18. Find the approximate lateral area of the traffic cone. All right, they said the radius is 5.7. So maybe I can draw that in here. Let me see here. Maybe I should redraw this cone. All right, so I'll just draw it like so. It's going to be a little sloppy. All right, so we have the circular base down here. And this is a circle. Okay, and they said the radius is 5.7. So I'll draw that in a different color. The radius starts here and goes to the circle. That's 5.7. And they said the height of the cone, they said the height is 18 inches, so we can draw that as well. The height just goes from the vertex. For a right cone, it goes right to the center of the circle, and it makes a right angle. And they said that's 18. All right. Now, they only asked us for the lateral area, not the surface area. So we might be in business. Because if you look at the surface area for the cone, we said it's pi r squared plus pi r L. Now this right here, this part right here, pi r squared, that's the circle on the bottom. That's the base. Or we should say base area. The rest of it is the part that is wrapped around, the orange part. So that part is the lateral area. And this right here is what we're actually trying to find. So we're not worried about the pi r squared. They said lateral area. Nevertheless, notice we need L for that formula. So unfortunately, we still have to do the Pythagorean theorem. The slant height is the slanted height from the vertex to a part of the circle, right on the circle. Okay, so that's going to be L. So once again, we need to use Pythagorean theorem. A squared plus B squared equals C squared. All right. As always, across from your right angle, that's going to be C. The other two sides are A and B, so I'm going to let A equal 18, and I'm going to let B equal 5.7. All right. Once you get the hypotenuse, it doesn't matter which is A or B. So A squared is going to be 18 squared. And B squared is going to be 5.7 squared. And C squared is going to be L squared. All right, you can multiply this out, or just take the square root from here and let the calculator do the work. The opposite of squaring something is to take the square root. You do the square root on both sides. Square root of L squared is L. Square root of this mess I'll do on the calculator. And I get 18.88. Okay, I had to round off, but I'm going to use 2 decimals to round off for now, and then I'll do 1 decimal round off at the end. All right, so now we're in business. We just want the lateral area, they said, which is pi RL. So that's going to be pi times the radius r, which was this distance right here, 5.7. Plus it's in the problem, in the write-up. And L we just found, that's 18.88. And let me see what they rounded on their answer. All right, they did 1 decimal, so that's what we'll do. All right, so pi times 5.7 times 18.88. And rounding off, I get 338.1. And their units were in inches. So the units on an area are going to be inches squared. All right, so let's try problems 3 and 4. Luckily, it's the same diagram of a right cone, so they want us to find the lateral area and surface area. Let's take a look. All right, so 2 problems in 1. Remember, lateral area is just pi RL. The surface area, pi r squared plus pi RL. You need to use Pythagorean to find L right here, the slant height. Please try it. All right, so this distance right here from the vertex to the circle itself, an edge on the circle, that's going to be your slant height, L. Okay, so we need to use the right triangle. You go across from your right angle, and that's your hypotenuse, C. This distance here is A. Doesn't matter which one is A or B. Okay, so I'll call this A and this B. So we're going to do Pythagorean theorem. A squared plus B squared equals C squared. Okay, A is 20, so A squared is 20 squared. B is 15, so that's 15 squared. And C is L, so that's going to be L squared. Opposite of squaring something is to take the square root. So I'm going to take the square root of L squared and the square root of this mess right here and use the calculator. Square root of L squared is just L. And this mess right here is just 25. Nice round number. Okay, so they asked us for the surface lateral area in number 3. I'll just cross this out. Lateral area, we said that was pi RL. So that's going to be pi. And this right here is the radius R, that's 15. So R is going to be 15. And L is the slant height we just found, that's 25. All right, so 25 times 15 is just 375. They did not say how they wanted their answer. So it's either 375 pi, or if you want to multiply it through and round off, that's going to be 1178.1. The units were in yards, so on an area, that's going to be yards squared. So either one of these answers is good for lateral area. Now for the surface area, I'll just do it right here. All right, we have pi r squared, so that's going to be pi. And this right here is r, that's 15, so that's going to be 15 squared. And we're going to add what we got for the lateral area, which was 375 pi. No need to go through that again. We have the lateral area already. Remember, this part of the equation is the lateral area. This part of the equation is just the base. That's the circle on the bottom. All right, 15 times 15 is 225. And that's times pi. And that's plus 375 pi. All right, 200 plus 300 is 500. That's 600 pi. If you wanted to round off or multiply it through, 600 pi is going to equal 1885.0. 1885.0. Once again, the units were in yards. So that is going to be yards squared. So it's either that one or that one right there.